Then I told my wife, I'd love to have a donut. She said, well, hey, they like donuts. Come once a week tomorrow. And I said, yeah, I've seen them and I can't think.
All right, let's get started. Thanks for joining this morning for our measuring rear ends and measuring and straightening rear end seminar. Um, let's just go ahead and dive right in. First of all, I just want to review real quick why we measure rear ends. Obviously, this is kind of a no-brainer, but the so many race teams don't measure their rear end housings on a regular basis. And when I say regular basis, you need to check your rear end housing after every race because they do bend and they do move, and they actually move quite easily. Um, we need to measure our rear end housings because it's our wheel position. So when your axle tubes are bent, we're changing our toe and our camber. The crazy thing is, a lot of times we won't catch the fact that our toe's off because if we're only checking, say, one side of the rear, or even worse, if you're only squaring your rear off the axle tubes or off a, say, a 4-bar length or something like that, you might not realize that you actually have toe and camber in the housing, and that's affecting your wheel position, and that's a critical measurement when it comes to setup. Rear end positions, specifically in the toe plane, are far more sensitive than front wheel positions are. So it's really important that we have the rear end housing straight. Another thing that'll happen, if you have, let's say we have toe in this right rear axle tube, well, then, and let's say you're squaring the rear off the right side, well, you'll square the rear back so that, by your alignment measurements, everything looks good because your rear's back in the position it's supposed to be in. The problem is what you've done is you squared the rear off of a bent axle tube, which means now your left rear tube is way out of whack. So those are the reasons. And actually, I'm gonna switch this over right here too. Sorry about that. Um, let some more people in. All right. Now you can see our rear end housing up here. So what we're just saying is it's critical that we have the axle. We know where the axle tubes are, and then we have the rear end straight, because if we had toe in this right rear tube, we go and square let's say we square the car off the right side wheel. Well, you're going to have the rear end looking square in the car. The problem is now your left rear is going to be hanging out to dry. Um, uh, so so let's just say if our right rear axle tube was actually bent, and we had toe in this tube, we go and square the rear up. So that means we get the right side tire straight. Well, now our left side tire over here on this side is going to be way towed in. And in fact, it can even exaggerate in some cases. So axle tube straightness is just critical. We want to stay on top of it. It needs to be checked every week because these things bend and move around like crazy. All right. Another thing that happens too when we have a bent axle tube and we don't realize it, it's actually putting our axle in a bind. So, which is not only is it robbing horsepower, but if you're running an open type differential, in other words, anything that's not a spool, it can cause the differential to not work properly, which can really goof you up. And we all that's considered binds. It can rob horsepower and affect the handling too. So let's talk about the measurements that we need to take when we're checking our rear. And I'm going to go over all the measurements. Now, we don't check all these on a weekly basis. On a weekly basis, we're just checking three things. But let's start off with going over everything. So The first measurement I'm going to take when I get a brand new rear end housing is I'm going to take an overall tread width measurement. Usually I'm taking this from hub face to hub face, but oftentimes I'll do it with the tires and wheels on the housing too. That way, depending on your wheel offsets, that way I know what my tread width is, specifically from a rule standpoint, to make sure that we are within the rules alignment on our tread width. And from a handling standpoint, I'm going to always compare my rear tread width to my front tread width. So I'm going to check overall tread width. Now, tread width is center tire to center tire. Track width is actually hub face to hub face. So you may hear both of those terms, especially when you're ordering a rear end housing. Typically, that's going to be going off of, it's usually going off of actual tube lengths, but sometimes they'll go off of actual track width, which track width is going to be hub face to hub face. So we have tread width, we have rear end offset. So most all racing rear ends are offset, and what that means is the pinion, the center line of the rear is not in the center of the two tires. Usually it's always offset to the left. So we have a shorter left side tube than we do a right side tube. What's important about this is in the car, we're going to put the wheels where they need to be to have our proper contact patch alignment to be lined up. Well, if our center section is not in the right place, then that means our drive line is not going to be lined up. So it's really important that we get we check the offset, we have the proper offset. So we've had cases, and this is especially important in like crate cars and things like that, low horsepower applications, when we're simply just changing the offset in the rear end and getting the pinion back in the right place so we get the drive line lined up, makes a massive difference in overall performance. So that is offset left to right. So I'm going to check that on the new rear. Finally, when it comes to actually measuring the rear on a weekly basis, I'm going to check three things. Number one, I'm going to check the pinion angle. Why is pinion angle important? Pinion angle is important because it will change your toe and camber. And we'll get to that here in just a minute. But I'm going to always check pinion angle. So I'm going to look at pinion angle. Pinion angle is actually the angle of the pinion shaft in the rear end from ground plane. So at what angle that pinion shaft is. On a quick change or even like a 9-inch, typically we're checking it right off the yoke. In this case, I can check it right off this plate. I can check it off the front cover. I can check it right off the front of the yoke. But I'm going to check pinion angle. So whatever my static pinion angle is typically how I measure the axle tubes. So in this case, I've got a rear end in my fixture here to measure it and or straighten it. So the first thing I'm going to do is when I put it in here is I'm actually going to take my little level and I'm going to set my pinion angle. And in this case, I'm going to set it to about 8 degrees on this one. So that's absolutely first thing. If you're checking the rear end of the car, number one measurement we got to check pinion angle. It's important too because sometimes we get to adjusting trailing arm lengths, or we get to adjusting forebar rod lengths, or our top bar lengths, or adjusting on our lift arm or our torque arm, and we forget that we made those adjustments at the track, and it goofed up our pinion angle. Pinion angle is also important from a horsepower standpoint as well. So that's pinion angle. The next thing I'm going to check is I'm going to check toe. My toe is, we know what toe is. Toe is the direction of the wheels pointing in or out. On the rear end, you have individual wheel toe. We have right side toe and we have left side toe, just like we do on the front end of the car. So I have to check both of these independently. I can't just take a set of toe plates and put on my tires and check toe and say that my rear end housing's okay. This is a common mistake. Well, why is that? Because I can have toe out on my right side wheel. Can have toe in on my left side wheel, and my toe plates are going to check that the rear is straight, but it's not. I've got toe out on the right side, I got toe in on the left side. And what you're going to wind up having is a rear that's all bound up, and robbing a bunch of horsepower, or a differential that's not working properly. So you have to check individual wheel toe. Now, how do you do that? We're going to check it in our fixture here, and I think that's an absolutely wonderful way to do it. But if you don't have a fixture, we got to come up with another way. And there's some simple ways. You can do a rotor to side bell measurement as a rough way to check it. You can X the rear out, but you need a method to check individual axle tube toe. The next measurement we're going to take a camber measurement. And camber is exactly what it is. It's going to be the angle of the rear wheels. We adjust rear camber like we would front camber. Now, some cars will run zero camber, and we'll talk about that here shortly too. But rear camber is critical. It's just like front camber is critical. Rear camber is critical. If we're allowed to run rear camber, and it's feasible to run, then we're absolutely going to run rear camber, because we're going to gain rear grip, rear side bite when that happens. So I'm going to check camber. Again, I'm going to check camber on the right and left. If you're checking camber in the car, you've got to remember, and this goes for toe as well, but more specifically camber. If you're checking camber in the car, you got to remember you have stagger. Stagger creates camber, not on the front, on the back. So stagger will create camber. So if I've got 2.5 inches of stagger, that's going to give me camber here. So let's just say I'm checking 1.5 degrees negative camber over here on the right side, because I've got a taller tire over here. Well, that always means if my axle tubes are straight, if I'm checking 1.5 degrees negative on the right side, I should be checking 1.5 degrees positive on the left side. The left side should always be exactly opposite of the right side if our axle tubes are straight. But kind of the same thing goes with toe. If I'm doing my wheel alignment and I see that my right rear tire is showing an 1/8 inch toed out, which means that my rear is an 1/8 inch back. It could mean that my rear is 1/8 inch back, or it could just mean that my right side is an 1/8 inch toed out. Well, as soon as I see that it's an 1/8 inch toed out, I'm going to come over and look and see where my left rear is. And my left rear should be showing an 1/8 inch toed in. It should always be the exact opposite, because the rear is all one piece. So whatever my right side is, the left side should check the opposite if the rear is straight, if the axle tubes are straight. Now, there are some cases where we purposely don't run the axle tube straight, and these are primarily asphalt applications. And that's because maybe the rules will allow it, maybe sometimes they don't. But if it's allowed, we will actually purposely run some toe in the axle tubes, and we will absolutely run camber in the axle tubes to take full advantage of that. There is a maximum amount of camber that you can run, and usually a good rule of thumb on that is you can absolutely not go over 1 degree of camber in the tubes unless you go to a 2-piece dry flange. So you need to stay under 1 degree of camber in the tubes unless you go to a 2-piece dry flange. I personally wouldn't even go that high until I have a 2-piece dry flange. Why? Because I don't want that axle running in a bind and robbing horsepower or messing up my differential. With a 2-piece dry flange, you can go on up from that but there's a limit to that as well. So again, on asphalt cars, will oftentimes purposely run camber, and we'll purposely run some tow. So it's very common to see, 15 to 30 thousandths of toe in on both the left rear and or the right rear and the left rear. There are also some teams that are skewing the rears with a more exaggerated toe, but for this video, we're talking about standard stuff. So it's very common to see 15 to 30 thousandths. That's a 64th to a 32nd of toe in on both axle tubes. Now, those are for asphalt applications. The reason, and let me actually back up for a second. Those are for asphalt applications that are running traditional rear suspension. So if you have an asphalt car and you're running a center pull type rear suspension, like a Seneca style rear suspension, where the trailing arm is mounted to the center of the housing, you want to run no toe or camber. The same way, if you have a dirt car, whether it be a modified or a late model, you want to run no toe or camber in the housing. Why is that? The reason is, with both of those style suspensions, both the 4-bar style on the dirt stuff, or even the 3-link on the dirt stuff, and the center pull style, you have a lot of pinion angle change. So as the pinion angle is changing, so when you get on the acceleration, the pinion comes up. Well, as that's happening, the axle tube is rotating. When the axle tube rotates, your toe converts to camber, and your camber converts to toe. So what you have happening on the track, when you're accelerating and decelerating, you've got your rear tires steering. And that's not what we want to have happen. We want any steer coming from the driver's input. Now, of course, you have rear steer happening as you accelerate and decelerate from a trailing arm standpoint, but we know what that is. We measure that. That's adjustable. This isn't. So this is a hidden gremlin that can absolutely cause you setup headaches. So good rule of thumb, if you have a rear suspension that allows for a lot of pinion angle change, that can even be an asphalt 3-link car with a rubber bushing or spring-loaded top link that allows, and you're getting a lot of travel in that. If you're having significant pinion angle change, the good rule of thumb is don't run any toe or camber in your axle tubes, because that is constantly changing. Now, on traditional stuff, if we don't have a lot of pinion angle change, I'll absolutely run toe and camber just to try to maximize that. There's pros and cons for both. I'm doing it both ways. So let's talk about one more measurement too, and this is a little bit more complicated measurement, but it's also the reason why we want to make sure that we stay on top of our rear end housing. And that measurement is concentricity. So concentricity is the center of this tube all the way through the center of the housing to the center of this tube. So if I shot an imaginary line right through the center of this tube, all the way through my housing, will it come out in the center of the other side? That's concentricity. We want the rear to stay concentric because we want to keep our axles out of a bind. So we want to keep our axles running straight. You can have a rear end that actually measures straight, but isn't concentric. And sometimes that happens when you have an axle tube that's been bent really bad and we've straightened it back. So we've got it where it's checking straight. The problem is it's running in an S pattern. So it's the wheel straight, but the axle tube is no longer concentric. So your axle now is having to run at an angle through that tube to get back to the differential, which will kill power and goose the differential up. So that's concentricity. Not an easy way to check for concentricity. there are ways. Not there aren't any super easy ways. The main thing to do is when you have a new rear end, is when we get a new rear end or a rear end's got fresh axle tubes in it, we check it, we make sure that it's straight, and then we monitor it on a weekly basis, and then you know if the rear end's if anything ever moves and it changes. We also have rules. So if that axle tube is bent, our rule generally is if it's been over 3/16 of an inch, and the axle tube just needs to be replaced. Don't try to straighten it, because the likelihood of you getting it straight and keeping it concentric is very low. Another thing that happens often is the axle tube will bend out here at the snout, but we'll straighten it here in the tube. Once again, you can straighten the rear, but it won't be concentric. So that's that. Make myself a note here. All right. Now, we're talking about straightening the rear every week. So what causes a rear to bend? Anything. I think sometimes if we load the car wrong, the rear end housing will bend. And yes, that's a little bit of an exaggeration, but rear ends bend. You don't have to hit anything, and you can bend an axle tube. It's kind of crazy. Sometimes we'll take, and we can hit the wall hard, bend the wheel all in, and the axle tube won't bend. But you can just scuff the wall or barely scuff another car with the sidewall tire. It won't even hurt the wheel, and you'll bend the axle tube. So it's all my chance, but we'll see tubes bend even if you don't hit anything. So which is why we have to check them on a regular basis. Now, let's jump in on how we're going to measure this rear end housing. Now, before we even start to measure it, there's a few things we need to know. Number one, when your rear is assembled, the torque on your side belts, the torque on your through bolts is critical, that it's even and torque properly. You can absolutely change the toe or camber in this rear end housing by how you torque the side belts. So we want to make sure that they're torqued evenly and properly in a crisscross pattern. Make sure when guys are taking brackets off that we don't over tighten and over torque those bottom bolts, because you'll take and change the camber in the rear real easily, which can also change toe just by torquing those bolts. The next thing, if you're running any of the bridges or the struts from the side belt over to the tube, let's just talk about those. I like them. I think it's a good idea from a strengthening standpoint. It's not a good idea from a straightening the rear standpoint. So we don't use the struts to straighten the rear, because what we found happens is you can turn the strut, you can get the rear to check straight, but what you've actually done is just flex the belt. So once again, you're getting the rear to check straight, but now our rear is not concentric, so our axle's having to run in a bind. And if we flex the belt too much, it can even cause the race, because our carrier race is right here. It can cause the race and the carrier to even move, which can cause even more bind or more problems. So when we're using the struts, whether they be on the front, back, top, what have you, we set the struts neutral. So we use them as a strengthening tool, not as a straightening tool. So when you're straightening the rear, we always take the struts back to neutral. Now, when you're checking the rear after the race, I don't adjust the struts because I need to see where the rear is right after the race. But if the struts are loaded, then that can absolutely cover up a bent axle tube. So that's struts. We talked about side belt torque. If you go and weld anything on your axle tubes, you need to weld a bracket, what have you. That's going to bend the tube. If you've got a mount on your axle tube, like a common on the asphalt stuff, will be a pattern bar mount. And then it's got struts, braces going over to the side belt. Once again, all that needs to be neutral because it takes very, very little to change the toe or camber in your axle tube. And if you've run any of the bridges, you know that. If you can turn those things very little and really have a significant effect on what your toe or camber is in the tube. Okay, so let's go ahead and look at straightening this rear, or checking it and straightening it. Now, the first thing I'm going to do, as we already said, is I'm going to set my pinion angle. So let me just double check this because I moved it. All right. Get my pinion angle set. In my fixture here, I can just simply rotate the rear because the rear is actually in V blocks. It's what the axle tubes are setting in. So that automatically centers up the rear. And I just set the pinion angle and then just lock these bolts down. I do not tighten these bolts down super tight because that can change my axle tube measurement. So I just kind of hand snug these down, or even with a wrench, you know. But I'm just barely snugging it, just so the rear and housing won't move. The next thing I'm going to do is I'm going to check the toe. Now on this fixture, I can do that a couple different ways. I can use a tape measure. In fact, let me grab a tape measure. I can use a tape measure, and I can measure from my side plate right here on each wheel over to my center point. And I can just do that from side to side. Now, what's important about that? Thank you. Yep. What's important about that is I measure from the side plates over to the center on each side. I'm not measuring the total toe because I can have my total toe checking properly, but both axle tubes can still be bent. So I'm checking each individual axle tube, and that's really critical on a weekly basis that I check each individual axle tube. Now, am I pulling the rear out every week to put in a fixture? No. I'm finding this out when I do my wheel alignment, that I've got one of my rear wheels are not measuring what they did the week before. Either my toe's different or the camber's different. If either one of those things checks wrong when I'm doing wheel alignment, then I'm pulling the rear end out and I'm putting it in my fixture and I'm checking it. And when I go to check it again, I'm checking individual toes. Now, instead of using the tape measure, I'm going to use this digital caliper that we have with this fixture. And all I'm going to do, I'm going to slide it over the little stud there in the center, and then I'm sliding over the stud out here on the end plate. Now, what this caliper does, so I'm going to turn it on, and then I'm just going to hit 0. All right, so now I've zeroed here. The next thing I'm going to do is I'm going to go around the back. And I'm doing the same thing, by the way, with my tape measure. So now I'm going to go around the back, and I'm going to check the same measurement on the back. So I'm showing that this rear is 60 thousandths, and it's a positive number. So that shows me that this rear is towed in 60 thousandths of an inch, which is a lot. That's a 16th of an inch on this axle tube right here. So I've got this tube is towed in 60 thousandths. And then, of course, I'll go to the other side and check the other side. The next thing I'm going to measure is I'm going to measure my camber. Now, I can rotate the rear 90 degrees and check it with the digital caliper. I typically don't do that because I don't check camber to thousandths of an inch. I usually check my camber just using my digital level. I'm going to use my level here, and then I'm going to check my camber. Now, the first thing I would do is I'd make sure that my fixture itself is level, and then I would check my camber, and it is actually showing no camber in this. Usually when you hit something, sometimes you can just bend toe, sometimes you can just bend camber. Usually it's going to tweak both of them. Uh, uh, so as we're doing our wheel alignment during our setup process, that's usually my indicator. My toe's a little off and my camber's a little off, which means it's more than just a trailing arm adjustment. It's definitely an indicator that I've got a bent axle tube. So pinion angle here, camber here, toe, and toe is individual on left side and right side. Again, if I was going to check toe, I'm going to measure from center out to my wheel, and then I'm going to come in the back, and I'm going to take the same measurement back here. That's 31 and an 8. Yep, about a 16th. Narrower here, so I've got about a 16th, not quite a 16th of toe in on this tube. And as far as measuring, that's it. It's really pretty simple and straightforward. Well, let's go ahead and jump into straightening. And before we get into that, though, on measuring, the theory here, it traditionally, like I can remember when we used to spin the rears around. So you take, and you can still do this. You can take your rear end housing out from in the car. You got both tires on it. We used to put the tires up in two wheels, and then what we'd do, we'd take in we'd put a piece of tape on top of the tire, scribe a little line on that tape. You can also spin the tire and scribe a line in the tire, which is a great way to do it. But I put a little line on my tape. I do that on both tires. And then what I would do is I would measure from, say, the wall over to that line on that tire, and then we would actually spin the housing. And if your axle tube was straight, that line isn't going to move. If the axle tube's bent, you'll see that line really moving. The challenge with the spin method is you then got to figure out, well, is it toe or is it camber? Which takes a little bit more time and a little bit more thought process. The other challenge with it is on today's rears, especially on our asphalt stuff, we're purposely running toe and camber. So if I use the spin method, every rear is going to check bent because they're purposely bent. They're purposely bent with toe or camber in them. So that doesn't work as well. I like this method because it isolates both the toe and camber completely separately, and it's just way more straightforward and quicker and easier to do. So again, back to the theory with doing it this way is we're only checking two planes. You don't have to spin the whole rear end housing to check the tube. If you check the toe plane, which is in and out, and you check the camber plane, which is the angle in and out, if you check both of those planes, it's the same thing as spinning the rear around. You've checked the entire axle tube. So that's toe and camber. All right, well, let's go ahead and let's play with straightening this tube. Now, I'm kind of doing this out here on our little trade show setup. So normally I would use a torch for this. And actually, before I even get into doing that, let's talk about the differences between using the heat and cool method versus using the jacking method. And we've done both. I personally like the heat and cool method better. And the reason I like the heat and cool method better is there's so much spring to the axle tubes. I have to put so much pressure on a tube and bend it so far and to let it spring back to straight. I feel a little bit more in control with the heat and cool method. And it's all in what you get used to and what you get good at. I'm also, and this has been years ago, but we had some axle tubes that actually exploded as we were jacking on them. I had a customer nearly have a heart attack because it's pretty violent. I mean, literally, I'm talking about the axle tube busted apart as he was jacking on it, which was pretty crazy. But that scares you away from jacking on them for a little while. So anyway, let's go ahead and get started. So the way the heat and cool method works too is when we heat the metal, it expands, and then when we cool it, it contracts. When it contracts, the trick is it's going to contract further than it expanded, and that's actually what moves the rear. And so let's just go ahead and do it. All right. So on this particular rear, this left side axle tube, we were towed out. Put my caliper back on here. We're towed in 60 thousandths. Now, think about the axle tube. Remember, I've got my pinion angle set. So if I need to adjust the toe in this tube, I'm going to heat either on the very front of the axle tube or on the very back of the axle tube, because that's the plane that I want to change. I want to change the toe. I don't want to change the camber. So if I was changing camber, I would heat on the top or the bottom. But with it being toe, I'm going to heat on the front or the back. Now, remember, when it cools, it shrinks more than it expands. So I need to tow this wheel back out, because currently it's towed in 60 thousandths. I need to tow it back out. So I'm going to heat the back side. Now, as I heat it, we're going to see here, it actually is going to tow it in further. But that's okay, because when I cool it, it's going to come all the way back and then back even further than what it started, and will wind up towing itself back out through the cooling. How much you heat, it's not an art, but it is a little bit of an experience thing. What I've learned that works pretty well is about a dime size spot. No more than a nickel, but about a dime to a nickel size spot. Now the trick with this fixture is when I heat it, and I wish the camera could show this, and I think we might go back and edit this video later when y'all rewatch it, that actually shows this more up close. But I'm just going to use this. Now, I'm using this because I'm in a trade show booth. I would normally use my torch for this, not a propane torch. The reason is this doesn't get hot enough, and the actual flame is not concentrated in a small enough spot. So it's heating a larger area of the tube. I want to heat a really small portion of the tube. So when I take and heat this, all right, so just right there, and I'm just using this little weak propane torch. Once it starts moving, it really starts moving. So I'm already out to 100 thousandths towed in. I started out at 60 thousandths towed in. Now I'm towed in 100 thousandths because I heated the back side of the tube. That's expanding this side of the tube, which is making this side move out further, which is making my front side move in. That's exactly what I want to happen, because now when I cool it, the trick is it's going to shrink this side more and straighten my tube back out. But I've got one more trick. When you just heat and cool by itself, there's a little bit of guesstimation that has to go on. In other words, you sometimes it'll move more, sometimes it'll move less. So we discovered a little trick, and here's what we do. If you look here, I've got a little strut on my fixture. And this strut allows me to cheat a little bit. And what it allows me to do with the strut, I want to tow this wheel back out because I was 60 thousandths towed in. What I can do, I can adjust my strut. And And I can do all this right with my hand. Overdone it a little bit. Yep. Oh yeah, I went past it. I can adjust this with my hand until I get my wheel back to 0. Or whatever the measurement is that you want it to be. What I'm doing, and then once I set my strut and I get my wheel back to 0, then I cool it. So let me give you another trick. When I go to cool it, there's a couple different ways I can do it. Traditionally, I always used a rag. I just would have a little pan of water and a wet rag, and I put my wet rag on here. We had a customer tell us that what they used was a frozen bottle of water. And this was a great idea, and it come from Tim Brown, so a little shout out to Tim. So what you do, you freeze a bottle of water, you just cut the bottom of the bottle off, and then we just set the water right up on the tube, and it will melt itself and form itself right to the axle tube, and it cools it down really slick and pretty darn quick too. So let's go through the process here again. I was towed in, so I'm heating the back of the tube. If I was towed out, I'd heat the front. But in this case, I was towed in, so I'm heating the back of the tube. I heat the tube up. Now, how much do you heat it? I heat it up using my digital caliper here until it tows in an additional 100 thousandths. So it started off at 60 thousandths towed in. I would heat it up until it's showing 160 thousandths towed in. After I get my heat in it, I then come over to my strut. And then I adjust my strut, and I use my strut to tow the wheel back out until it's back to 0. So my strut tells it where to cool to. Once my strut's set, then I come and I take my water or my ice bottle and I cool the rear down. Once it's completely cool to the touch, what I'll do then is I'll take my caliper. I'm going to release my strut, make sure that my strut is neutral. And then I'll take my caliper back on it. I'll have to re-zero it. And come back around and check it. When you get good at it, and it all depends on how much the rear is bent. If the rear is bent 60 thousandths, I'll probably heat on it twice and get it, certainly within 10 thousandths of an inch. If it's bent less than that, I probably would just heat on it once. If it's bent, an 1/8 inch or 3/16 of an inch, it's going to take me, I might have to heat on it 3 or 4 times to get it back to where I want it to be. And that's because I'm not overdoing it in any one spot. Again, I'm heating just a little dime, no more than a nickel size spot. If you overheat it, it won't move as much as if you do it right. Where at on the axle tube do I heat? Well, I usually like to heat out closer to the hub. A lot of that depends on my bracket situation. Now, if I've got a tube that's really bent and I need to straighten it, I'm going to pull these brackets off so I can have full room to straighten it. But if I'm just tweaking it a little bit, I'm kind of looking to see what kind of real estate that I have to heat it. Another thing I'll do is, let's say I know that I'm towed in, but I've also got some camber here. Well, I'll just think to myself, so let's say I've got some negative camber and I'm towed in. So that means I got some negative camber. Well, to put positive camber back in it, I need to heat the bottom of the tube. Well, with being towed in, I need to heat the back of the tube. So what I'll do, I'll split the difference. If I need to put tow and camber both in it, I'll split the difference. Instead of being at, say, 9 o'clock or 3 o'clock, I'll go in between those, and that way it'll bend it both in the camber and the tow plate. So just use kind of some common sense on where at you want to heat it. once you've heated the rear in a spot, you can't heat it back in that same spot. It ain't going to move. That spot's dead. So you need to move over a spot. Now, let's talk about something else. You're going to say, well, that's great for steel axle tubes. What about aluminum tubes? I use the same method on aluminum tubes too. So you can heat and cool on aluminum tube as well. I use the strut the same way, and it does work. Aluminum tubes are a funny thing. Sometimes they straighten real well. Sometimes they won't. And this is even when you're jacking them. Sometimes you have to way over jack them. Sometimes you're under. Now, there are some guys, and we actually build the pieces to do this with, that like to jack the actual snout on the rear, and you can totally do that. You just have to be careful about that you don't bend the snout and get the concentricity off on the rear. But there is nothing wrong with that. On some of the dirt stuff, it's very common to bend just the snout. So using the jacking tool and just getting the snout tweaked back is not a crazy idea. I personally, I'm a steel tube guy, so I like steel tubes. I like the weight. The weight's where it needs to be on both the rear tires for traction. And I like the way a steel tube straightens better. One thing that we see sometimes in the aluminum tubes is on the track, they'll flex, and we see this even just pulling cars down and stuff. They'll flex. Now, the great part about aluminum tubes is they have great memory. So when you come back in the shop and check it, it checks good, and you're happy. I said, man, that's great. But on the track, it's not happy at all. So I tend to prefer the steel tube because usually when it bends, it bends and stays bent. It may cost me a little bit more work, but it costs me more work because I know where it is. Where on the aluminum, I don't know as much. Final thing that you got to keep in mind when you're doing straightening rears. Not only will axle tubes bend, but the side bells will bend as well. You don't want, if you've got a side bell that's bent, we don't want to straighten it in the axle tube because, again, the rear's not going to be concentric. So how do you know the difference? On this fixture, I've got a little way to measure it. If you it's probably hard to see on the video, but these little caps that go down on here are extended out. They got little tabs on them. And what I do, I take my caliper, and you can use a tape measure too, but I'll actually take it on measure from the side bell right over to this tab. And then I check it on the front and the back. And that tells me the toe on the side bell. And I can rotate the rear up and check the on the camber plane too, the same way. You can bend an axle tube, and let's say it's really bent, it's beyond straightening it. So you go and you spend all the time to pull the tube out, put a new tube in it, and only to find out that the rear end is still bent, because your bell is bent. So the bell is something that needs to be checked. Some rear end straighteners, and there's a lot of great places around the country to send your rears to have them straightened. Most professional teams are going to straighten the rears themselves unless they're really close, because you're having to tweak on these things on a very regular basis. But for most teams, it's not as feasible, so they'll send the rears off. And if you've got a side bell or something bent, it's probably the best thing to do. But some rear end guys will take it. They'll actually chuck up the bell, and they'll chuck up the tube in the lathe and check the bell, which is a great way to do it as well. But this is a quick way to check it right off of these. I'm trying to think of a good way to check the side bell minus having something like this. or putting it in the lathe, and I don't have a good answer for that right off. So if you think you got a bell bent, you probably need to uh, set it off and let someone check it if you don't have the ability to. You could always set the bell up on a known flat surface and dial indicate over into your tube and spin it like that. But this one right here is a real quick and easy way. You just anytime you're seeing any kind of significant amount of toe, you need to check the bells first, and then worry about straightening the axle tube because you don't want to straighten the tube that's got a bent bell. And I think that's the main parts of it. We talked about where to heat the axle tubes, how much to heat it. You'll see when you heat the tube properly in that soft spot, it will, and once it's cool, that spot will either pucker in or push out just a little bit, and that's normal and that's critical because that's how it actually shrinks the metal. So you should have some metal deformation there. It either should pucker in just a little bit or it should push out just a little bit because that's actually where that extra metal has gone to once the axle tube has straightened. Any other questions? Like as always, send them in to us. Email us, text us, call us, and we'll try to answer those the best we can. Thanks for joining us, and we'll get this posted as soon as possible.